Hi, today we're going to be working with functions of an equation. So in the upper right hand corner, write functions. You can find help with this on page 136. Do your bell ringer here. You need to write your bell ringer out. That way you can see your table and your ordered pairs. So finish the table in which you've been given and write the ordered pairs to the right. Write the clear target, today's clear target. I can determine whether an equation represents a function. Go ahead and press pause while you do this. As you can see, the x value, or the domain, is the input. If you input 0 in for x, or substitute it in, 0 times 2 is 0. Therefore, y is equal to 0. So here, if you have y is equal to 2, now you're going to input x is 2. Y equals 2 times 2, which is 4, so y is 4. Same thing on the next problem. You have y equals, now you're going to input the x value, the domain, in for x, so 2 times 4, which is 8. Here you have y equals 2, and then x is now 6, 2 times 6, which is 12. Now you have the input, the domain, and the output, or the range. So let's make our ordered pairs based off our input-output. You have 2, 4, 4, 8, and 6, 12. This is how you finish the table based on the information you have. Your input and your output make your x, y, or ordered pairs, or coordinate pair. Next to your notes, let's write down this equation. Y equals 2x plus 3. With this equation, we know two things. We know that y is the output. And we know that the x value is the input. Pause for a few minutes. Copy this into your notes. Now that you have this in your notes, let's apply this by creating a table. We need a table of values in order to understand the ordered pairs that go with our input and output. So create your table. Start with your input value. And then you have your output value. Now this is what's known as the function rule. And the function rule goes here. Because the way the function goes, whatever you have as the input creates the output using the function rule. So we're going to pick up, let's choose 5 points. Have some negative numbers, -2, -1, 0, 1, and 2. Really, we can choose any numbers we want to put in for this input because we'll get an output for them. I just chose 5 random numbers. Let's substitute in our inputs to get our outputs. So y equals 2 times -2 plus 3. Go ahead and pause here. You finish up the rest of this, input each one, and figure out what the output is. If you follow along with your table, you should have an input of -2 and output of -1. An input of -1 and output of 1. An input of 0 and output of 3. An input of 1 and output of 5. An input of 2 and an output of 7. So now let's change this over. Your teacher's going to hand you out a graph. I want you to take this graph into your notebook, as you can see here. So take your graph and then label your y and your x axis. Let's take these points, or these inputs and outputs, and make some ordered pairs. Write them next to the graph in that little space you have provided. So x, y. So I have -2, -1. negative 1, 1. 0, 3, 1, 5, and 2, 7. These are all the ordered pairs that I've created by putting in input, using the function rule, and getting the output. So now let's use our graph to graph these ordered pairs. Since my x value is negative 2, I go back 2. My y value is negative 1, I go down 1. X is negative 1, y is positive. X is 0, y is 3. X is 1, y is 5. X is 2, y is 7. Now that you see this, you should notice a pattern. What pattern do you see here? Good, a linear line. So if you connect these points and you draw a line straight through them, you get what's known as a linear function. Well, just because we chose these points to put as an input doesn't mean that they're the only points. If you look at my line, are there any points on there that are on the line that we didn't use? Maybe you saw this one right here. That one's easy to tell because it's right there on the grid line. You have this grid line here and this grid line here, and it crosses our line right there. And that gives us a good solid point. That point is negative 3 for x, and it's negative 3 for y. Well, let's check that one with our function rule. Our function rule is y equals 2x plus 3. If I put in negative 3 for x, I should get negative 3 for y. So y equals 2 times negative 3 plus 3. 2 times negative 3 is negative 6, and negative 6 plus 3 is negative 3. So our y is equal to negative 3. So the input actually works to make the output. What this means is that every point on this line actually represents a solution to our function rule. We just choose easy numbers to work with because we can work with them easier with mathematics. I'd like the sub to pass out this sheet, and I want you to work this problem right here. These are all the input values given to you. I want you to use our function rule, and I want you to come up with the output values that go with this. Please press pause and finish this table. So now you have how the input creates an output using the function rule y equals 3x plus 1. Use the same scenario and answer this. Please press pause. When you're done, start up. So with an input, as you see over here, you should get an output of negative 3, negative 2, negative 1, 0, and 1. Now let's make a table. Doing roughly the same of what we saw in our notes. This is going to be great. So I want you to take a few minutes of your time, and I want you to finish in the input and output. Write your ordered pairs here. And then I want you to graph your ordered pairs and connect those points, drawing a line through them. Go ahead and press pause and complete this. When you complete it, go on to the next section. Number 4 talks about the two types of temperatures we have, from Fahrenheit to Celsius. There's an actual formula that is used to convert our Fahrenheit to Celsius. So if the Celsius is one of these degrees right here, we can put it or input it into our formula to get our degrees in Fahrenheit. So we're going to do that real quick, and I want you to go ahead and input this in. Once you've inputted this in, solve for the Fahrenheit, I want you to graph it. This, again, will be graded. You'll be turning this in at the end of class. So go ahead and do this. Press pause. Once you're done, press play. Take a few moments to look over this. See if you can figure out what it's asking for. Go ahead and press pause while you take about 30 seconds to look over this problem. Alright, now let's discuss it. For which function rule is shown by the table? So if these are all function rules, and these are all the input values, then each one of these should make an output if plugged in to one of these equations that match their output. For instance, if it's input of 1, it must create a 5 as an output to be the function rule. So if I use this one, y equals 5x. If I use this function rule and I put in 1, so y equals 5 times 1, do I get y is equal to 5? Yes. So now let's use the next one. Let's use an input of 2. Y equals 5 times 2. Do I get an output of 10? Yes. Let's go to the next one. Y equals 5 times, now our input is now 4. Do I get an output of 20? Yes. And finally, y equals 5 times 8. Do I get an output of 40? Yes. So this function rule does work for the table provided. But just to make sure that the other ones don't work, let's try this one. If I input 1 for x here, does 1/5 equal 5? No. If I input 1 here, does 1 plus 4 equal 5? Yes. So the input of 1 works, but does the input of 2? If I input 2 here, 2 plus 4 is 6, not 10. So the input of 2 doesn't work with this function. And then finally down here, well, 10 times 1 is 10, and that doesn't equal 5. So inputting 1 for x here doesn't work either. So the only function rule that we can say works is y equals 5x. So when given an input, they should all equal out to their output. And you're going to have to test several of them to make sure that it's true. Now that you know what a function rule is, this is the rule that creates an input, or when you put an input out into it, will give you an output. So here's what you have. Sometimes you're given a set of ordered pairs, which is right here. And you're needed to find a function rule that describes how they get to the outputs from the inputs. Try using addition and subtraction first, and if that doesn't work, try putting in some multiplication and division to get you there. For instance, what plus 3 gives me 7? Good. So if I took the x value and I added 4 to it, I get 7. Does that work true for 5? No. 4 plus 5 is 9, so this actually doesn't hold true for that one. So addition or subtraction doesn't work, so we're going to have to try multiplication. So 3 times what gives me 7, or closest to 7? Well, 3 times 2 gets me close to 7. So we're going to say 2 times our input, which is x. That gives me 6, because 2 times 3 is 6. And to get to 7, I have to add 1 more to it. So 2 times 3, which is 6, plus 1 gives me 7. Good. Now let's see if that works for the next one. 2 times 5 is 10, plus 1 gives me 11. All right. 2 times 6 is 12, plus 1 gives me 13. And 2 times 8, which is 16, plus 1 equals 17. So our function rule is y equals 2x. And that's what you want to end up with. You have to make sure that it works for each one of the given ordered pairs. So when you check it out, it must, whatever the input is, must give the output that you're looking for.